Welcome back to our discussion on using the Git distributed version control system. So in the last video, in the last lesson, you learned how to use the Git status command. All right. And of course, by now you know how to do a commit, whereby we initialize a Git repository. And then whatever changes we make, we can do a git add, and subsequently we can do a git commit with a commit message. Now what I want to do in this lesson is to show you the usefulness of Git, whereby it allows us to be working on different versions of our software, of our project. Okay. So let's imagine that I have my program here from the last lesson, and I want to make a change to it. Okay, so this could be a scenario where, let's say I give you a quiz, and the quiz has 5 questions, and each question builds up on the next question or on the previous question. So instead of having to do everything, we can solve one problem, commit it, and then move on to the next problem. Okay, so the idea is we want to be able to be working with different versions of our program. So let's say that I want to make a change and I want to delete this increment function, and instead I want to create a decrement function. Okay, so in essence it's 2 things. I want to delete increment and I want to add decrement, and of course that would mean I have to make changes in main as well. So let's say I am happy with this. However, I do not want to change this because I do not know what's going to be the outcome of the changes I make, which is adding decrement. So what I can do, I can tell Git to sort of make a copy of what I have, and I want to be able to work on that copy without affecting the original. Okay. Now, if it turns out that after I have made the changes to the copy, I like what I have and I want it to now be reflected in the original, then I can go ahead and merge those two. Okay. In this lesson, I want to show you how to actually make a copy of your program, of your project, so that you can work on it in isolation, separate from the original. Now, in Git terminology, we say that the copy, we're going to call it a branch. Okay, just like how you have a tree, and as you go up the tree, you have different branches, and each branch is different from the main trunk. Okay, so consider this the trunk and the branches as copies. So what I want to do, I want to create a branch so that I can work independently of this, the original. Okay, so the command we're going to use is the git branch command. Now, when I type git branch by itself with no argument, it tells me how many branches I have. And by default, we have one branch, which is main, which is like the trunk. So every code, every piece of code you write will be saved, will be committed to this main branch, this trunk. Now, if I want to tell Git that I want to create an offshoot or create a new branch so that I do not modify the original, so that I want to experiment, So branches allows us to experiment with our code without affecting the original. Okay, so let's create a new branch. So git branch, and let's say I want to call this branch decrement. Okay, so add decrement. Okay, so git branch and the branch name. Now if I do git branch again, I will see that I have two branches, though the asterisk tells me which of the branches has the focus. And so even though I created a new branch, the focus is still on the main branch. So to tell Git that I want the focus to be on my newly created branch, I will have to use the git checkout command, followed by the branch that I want to check out, which is named add decrement. Okay, so if I do git branch again, we'll see that the asterisk is now on the add decrement branch name. Now, what is the consequence of this? The consequence of this is Git knows that whatever changes will be made only on this new branch. Okay? That's the consequence of what we just did. Okay, so let's go ahead and let's write our code. Okay? Okay. So what I'm gonna do, I'm gonna change this to decrement. Okay. This is decrement. And then I'm gonna say return value -1. That's my decrement function. And so I should get 2, right? So let's run this. Let's say git, sorry, not git, go run main.go. All right, so I get 2. And let's say I don't want this cookies, I don't want this line here. I don't want to see that anymore. Okay. Great. It works. So let's commit this program, these changes we've made. So let's verify. If I say git branch, right, we are on the branch we just created. So I'm going to do git status. Okay, so clearly I made changes. All right, and so I'm going to say git add main.go. Good. I'm going to say git status again. Oops. Git status. Great. And finally git commit, a commit message, added a decrement function and deleted the increment function plus the, yeah, let's leave it as that. All right, great. Now, you might be asking, so what if I want to go back to the changes I originally had? Let's say I looked at this and I realized, uh-oh, I was not supposed to add a decrement function. I was not supposed to delete hello cookies. Okay. So this is a branch. It's separate from the original. So if you want to see the original, okay, all you have to do is to check out the original. So git checkout main. Okay. And look, we're now back working on the original. See that? So Git knows that when I check out main, it should give me back the original code in the main commit. Okay, so if I say new terminal and if I say git log one line, all right, so we are pointing to main, right? Now, if I decide to go back and say git checkout, what was the name? Oh, okay, let me just do git branch to get the name. Oh, I didn't, okay, so if I say git checkout, add decrement, okay, notice we switch back to that branch. We switch back to the code in that branch. So now we have decrement, we have decrement. And if I say git log -- one line, what do you notice? The head now points to this branch, okay, to this branch. So notice I am working in isolation from the original code. So what is the consequence of this? The consequence is I can experiment and make changes on an offshoot of my program, being confident that whatever changes I make will not be reflected in the main program. And so, for example, in software development, you could have the software that has been released, okay? And then as a developer, you could create a branch of that, and then you could start adding new changes which will be used for the next version of the software. So you're not affecting the release version of the software, even though you're making changes to it. Although those changes are isolated. That's why you have the branch. And once your manager or your supervisor is happy with the code you have written in that new branch, he or she might say, okay, I like this, what you're doing. Let's add it back to the original. Okay, and that is called merging. Let's merge this new code to the original. But we will look at merging in the next lesson. In this lesson, I want you to understand the importance of branching. Okay, so again, notice we are on the branch where we're altering the code. And if I check out the main, okay, I need to keep typing that. If I check out main, notice at the top how the code automatically switches back. All right, and of course, if I run git log again, notice that the head is pointing to main. Okay, now where am I? Let's see, git branch. Okay, so you need to always be mindful of where you are, which branch you're on, because you want to make sure that you're in the right branch so that when you make a commit, you're committing to the right branch. Okay, now let's assume that you are experimenting and you realize, you know what, this is not leading anywhere. This code I wrote is just not what I'm supposed to do. In a sense, you want to delete the add decrement branch. Right? You did your experimenting. It didn't take you anywhere. It's like it was wasted effort. Whatever code I wrote didn't solve or didn't do what I wanted it to do. So let's delete this branch. So how do I delete a branch? Well, you got to make sure that you're not on the same branch. So if I want to delete add decrement branch, then I have to make sure I'm on main. Okay. If I don't do that, so let's say let's say I go to add decrement. Okay. Now I want to delete this branch. Now obviously you can't delete a branch if you are on that branch. And so if I issue the git -d command to delete the branch, git branch -d, and I say add decrement, then obviously that should be an error, right? You cannot delete a branch that I am on. So let's check out the main branch. Good. And so now I will attempt to delete this branch again. Okay, so it's telling me you are trying to delete a branch that you have not merged back into the original. But I already said earlier that this code I was writing in a decrement is not good. It's useless code. It didn't help me solve my problem. So I would like to delete it. So Git is telling me, are you sure you want to do that? And so if I want to do that, it tells me use a capital D instead. If I am sure that I want to delete it, use a capital D. And I do that. And so my branch has been deleted. And so if I say git branch, I only have one branch. Now, under the rare occasion that you wake up the next morning or you go drink some coffee, after you've deleted your branch, you go drink some coffee. And while you're drinking your coffee, you realize the code was correct. It's what I wanted. Uh-oh, you deleted the branch. So what do we do? Well, to get back your branch, you will say git reflog. Okay. And what this command does is show you information about where the head previously was. So notice our head was pointing to here. And actually, I think it should be shown to you anyway. So we need to get back our add decrement. Okay, we need to get back our add decrement. So what I need is to get the Git ID. Each commit has a number, a code attached to it, which is my Git ID. Okay, and so if I check, okay, here. Okay, notice it's 4E1256E, and here, yeah, it's the same thing, right? 4E1256E. All right. So it seems that our Git ID is 4E1256C. And notice the one from main is E6CA89D6, right? So what I want to tell Git is, can you give me back that branch? So all I'm going to do, I'm going to say Git, all right? And then I'm going to check out, okay, the -B option. So git check, git check out with the -B, which means branch. And I am going to put the name of that branch, so add decrement. And I'm going to copy the ID, which is 4E125C. Paste that. Enter. Okay. And so it says switching. Now let me see git branch. All right. Now, the moment of truth. You notice I get back my code. So it did work because I got back the code. Okay. Okay. Now let's assume that we really want to delete it now. Okay. On second thought, you realize, yeah, I was right. It's not the right code. So let's just delete it. Git dash D. I'm on the branch, so I have to switch, right? So git checkout main. Okay, so now we can delete. So git branch dot delete add decrement. Okay, so of course we need to use a capital D, and that's it. So here's the thing: when you delete it, it's sort of in limbo. We say it's dangling. It's a dangling commit, and so eventually Git will realize it's dangling, and then Git will clean it up. It will remove it. Okay, it will remove it so that it can clean up or release the resources that it is occupying. So if you ever want to get back a dangling commit using git reflog, make sure you don't take too long to get it done. Otherwise, it will be garbage collected by Git and it will be gone forever. Okay, so one other thing I want to show you. Okay, so we're back to our original code. Let's do this. Let's say git log one line. Okay. Now, another useful thing about Git is you can see those snapshots of the code that you committed. So let's say after writing this code, you realize, or your lecturer or your supervisor or someone asks you, what did your code look like when you first created it? And then you will do git log and you'll say, okay, the first commit I made had this Git ID. So is it possible for me to actually see that code? What did that code look like? This is the code we have now. I want to see what the code looked like at this moment when I committed. So we are able to do that. All right, we're able to do that. And so what I can do is to simply do a git, okay, and a checkout. But what I want to check out is this Git ID. Okay, so I can check out a branch, or I can check out an actual commit. Okay, and so Git will tell me, okay, it will say you are in a detached head state. Okay, what does that mean? Well, if I do git log --one line, you'll notice that my head is not pointing, there's no arrow which is pointing to main or pointing to some branch. It's actually saying that I am pointing to an actual commit. So that's what I mean by a detached head state. And it's telling me, it says you can look around, you can maybe write code, make changes, and then you can just switch back to main. You can just check out main, and everything will be gone and it will be back to normal. Now, if I ever want to create a new branch from this position, then I'll have to do git switch -c and a new branch name, or git switch dash to undo that change. Okay, so I don't want to create a new branch from this initial position. I just wanted to see what the code looked like, and here we are. This was my first commit. This was my initial commit, okay, which was fmt hello cookies. And this works for any number of commits you make. So it's always a good idea, after you make a change to your code, you don't need to wait for it to be a big change. You can write a function, do a commit. Write another function, do another commit. So you'll have like a history of all the code you wrote. And so by using a git checkout and by placing a commit ID, Git ID, you can go back to how the code looked like when you committed at that instant. And so if somebody comes back to you and says, what code did you write last month? Well, you could just do git log, check all your commits from last month, and then you could go on to one of them that you are interested in. Okay, so I've seen the code. I want to go back to the original, so just git checkout. Not the original, but go back to what I have now. Git checkout main. And now I'm back to the main code. Okay, so notice this is how we do branching. This is how we are able to keep the integrity of the original code while experimenting and adding changes to it. So to make changes, we create a branch and then we work on that branch. And Git will know that they are two separate things. Now you will reach a point where the code that you have experimented with, the code that you are developing, it's nice code, it's useful code, and you want to incorporate it into the original. And then that's where you do a merge. The merge, we'll talk about that in the next lesson. So for this lesson, you should know how to create a branch. You should know how to check out branches, meaning switching from one branch to the next. You should know how to delete a branch when you no longer need it. You should be able to recover a branch if you need it. And of course, you should be able to visit an individual commit so that you can see its associated code. And this is called a detached head state. So once you can do those things, then you have learned what you need to learn in this lesson. Okay, so in the next lesson, we're going to look at actually merging, where we make a change in a branch and then we merge that code into the original so that it's now a part of the main branch. Great, I'll see you in that lesson. And once again, this is an introduction to the basics of Git, and this definitely beats having to create multiple directories with different versions of your code. Version 1, version 2, version 3, and you're having to switch between the folder directories and then having to inspect what you did. No, Git does all of that for you. So all you have to focus on is writing code.